Welcome to the walkthrough of the specification, skeletons, and tests for Assignment 4. The purpose of this assignment is to deepen your experience using Java's functional programming features and their integration with Java's completable features framework. In particular, in this assignment, you'll develop an app that uses Java's completable features framework in conjunction with Java's sequential streams framework to obtain, store, and transfer images asynchronously in a pool of threads. The code you'll write here has a GUI and runs as an Android app. Please use this GUI along with the unit tests outlined below to help debug and evaluate your solution. The following resources may be helpful in completing this assignment. Detailed overviews of Java's completable features framework are available in the async videos in the CS5253 Brightspace contents page. Likewise, good overviews of Java's completable features framework appear here and here online. I also highly recommend you get the book Modern Java in Action to learn more about Java's completable features framework. The image crawler app is packaged as a project using the latest version of Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 4, however, you only need to be aware of the following directories. The image crawler crawlers directory, which contains the skeletons you need to fill in, as we talked about below. Image crawler source tests, which contains a set of unit tests that exercise the features you're implementing and are used to evaluate whether you've correctly satisfied this assignment's requirements. And app source Android test, which contains an Android Studio instrumentation test that runs your app automatically. To compile this code, you need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 29, so you need to select an emulator that uses an API greater than or equal to 29. I recommend API 30. If you don't already have an Android emulator, you can create one by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here tasks to provide a working solution. Please don't change the overall structure of the skeleton, just fill in the to-do tasks and don't delete the to-do tags. In particular, you need to finish implementing the following to-do tasks for this assignment in the image crawler crawlers folder. First, you'll need to complete the to-do tasks in various methods in the completable future crawler.java file to obtain, transform, and store images asynchronously. This class uses the Java completable features framework to perform an image crawler asynchronously, starting from a root URI. Depending on the parameters used to run the app, images from HTML pages reachable for the root URI are either downloaded from a remote web server or read from the local file system, transformed locally, and the transformed results are then stored in the local file system on the Android device. You'll also need to complete the to-do tags in the student.kt file to set the type field to include just graduate or undergraduate, depending on which version of the assignment that you're implementing. Obviously, for this class, you'll be implementing the graduate version. The bulk of the code for the app is provided in the skeletons. In fact, a complete solution using Java 7 features is provided in the sequential loops crawler.java file. You'll therefore convert this Java 7-based class to the completable features class that uses Java completable features. Your solution should use no loops or if-else statements in this assignment and instead use Java completable features methods and functional programming features. Your solution will be considered correct if it passes all the unit and instrumentation tests, is commented thoroughly, and addresses my review comments. Skeleton code for this assignment is available here in my GitHub repository. Now that you've long since set up your GitLab account, you can pull this skeleton code into your repository, read it carefully, and complete the to-do markers. Unit tests in the image crawler source test folder are provided to increase our and your confidence that your implementation is working as expected. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on these unit tests to detect problems in your code. Assignment 4 is a bit more complicated than some of the previous assignments. In particular, the asynchronous nature of Java's completable features framework may take some time to get used to, so please start the assignment soon. Ask questions in class, office hours, and on the Piazza discussion forum. As usual, the app, image crawler skeletons, and unit tests are extensive, though you don't need to understand them all to complete your solution successfully. Now that we've walked through the specification for Assignment 4, let's go ahead and take a look at the skeleton file. To do this, we'll click on completable features crawler.java, and this discloses an implementation strategy that uses Java's functional programming features, Java's completable features framework, and Java's sequential streams framework to perform an image crawl asynchronously starting from a root URI. Images from an HTML page reachable from this root URI are downloaded from a remote web server or the local file system, and the results are stored locally in files on the Android device that can later be displayed to the user. Let's start by taking a look at a field you have to implement, where you'll have to implement the M0 field, replacing null with the completable future method call that will store a completed future with a value of 0. Let's go ahead now and take a look at the main entry point method into this class, which is called perform crawl. This performs the crawl asynchronously. It'll wait until the processing is done and it will return the result. Obviously, it's supposed to call a helper method that we'll see in a moment. And this perform crawl method is the only method in the class that should call join, and there should be no calls at all to the get method. So just call join once and once only. So you return 0 with your solution here. Obviously, the method this is going to call is going to be called crawl page async, and this will create and use a Java sequential stream that in turn will use a factory method to create a one-element stream containing just the page URI that's passed as a parameter. It'll then use an intermediate operation to filter out the page URI if it exceeds the maximum depth or has already been visited. It'll then use a different intermediate operation to call the method crawl page helper and return the total number of processed images. And finally, it'll use a terminal operation to get the total number of processed images from the one-element stream. Parts of this should look somewhat familiar to what you've done in previous implementations because it's kind of the same pattern. And the implementation that you do here is to replace return null with your solution that does those steps. Let's now go ahead and take a look at the crawl page helper method. This will invoke 4 private method calls that work as follows. First, you'll get a completable future to the HTML page that's associated with the page URI parameter. And this page, of course, will be downloaded asynchronously. Then, concurrently or in parallel, you will get a completable future to the number of images in this HTML page, which themselves will be downloaded, transformed, and stored asynchronously. And then concurrently to that, you'll get a completable future to the number of images linked from this HTML page, if any, of course, which are downloaded, transformed, stored asynchronously and recursively. And then finally, you'll make a method call that will return a completable future that combines or sums the 2 completable futures after they both complete running asynchronously. So once again, you replace return null with your solution. Let's now go ahead and take a look at get page async. This method is going to load the HTML page at the given page URI asynchronously and return a completable future to that page. This method should use one of the classic completable future factory methods, and it'll also use a method that's defined on the m-wedge-page crawler field. And once again, you replace return null with your solution. Let's now go ahead and take a look at get images on page async. This takes a completable future to a crawler page object called the page future, and it will return a completable future to an integer that contains a number of images processed on this page. This method should call the get images on page and process image methods via a fluent chain of asynchronous completion stage methods. So once again, you replace return null with your solution. The next method is called crawl hyperlinks on page async. That's a bit of a mouthful, but it basically takes a completable future to a crawler page object called page future and a depth, and it'll return a completable future to an integer containing the number of images processed on pages linked from this page. This method should use a completion stage method to call the crawl hyperlinks on page helper method asynchronously. And as is often the case, we replace return null with your solution. The next method is a real simple one. It's very cool. It's called combine results. It takes 2 completable futures to integers, one called images on page future and the other called images on page links future. And it'll return a completable future that synchronously combines and sums the results of the 2 completable future parameters after they complete running asynchronously. So this is a good example of joining the results of 2 previously sort of forked off asynchronous tasks to get the results. The next method is called crawl hyperlinks on page. As you can see here, it takes a crawler page object and a depth. And what it's going to do is it's going to return a completable future to an integer that will contain a count of the number of hyperlinks accessible from the given page. This method is pretty cool. It's very interesting. It should consist of a Java sequential stream that contains various aggregate operations like map and collect, several completable future related methods such as then apply and futures, collector int stream to future, and other helper methods such as get page elements as strings and perform crawl async. And as always, replace return null with your solution. The next method is called process images. It takes an array of URLs using your array class that you've done in earlier projects, and it'll return a completable future that contains a count of the number of images that were downloaded, transformed, and stored from this array of URLs. This method should consist of a Java sequential stream that uses aggregate operations such as map, collect, and flat map, several completable future methods such as futures collector stream to future, and also then apply, and other various methods such as download and store image async and transform image async. These are the things that you should be calling in here. It's a fairly complicated method. It's got some really, really cool things in it, and it'll help you see how to integrate streams and completable futures together. The next method is called transform image async. This returns a stream of completable future to integer objects that will indicate success with a count of 1 or failure with a count of 0 of the images processed by converting the transforms in the mTransform field into a sequential stream. This method should contain completable future methods like then apply async, a stream aggregate operation like map, and a helper method, transform image. It's a little tricky to get this right. The thing to remember here is that the stream that is going to be taking each of the transforms from mTransforms and the mTransforms field, converting it into a stream, that stream needs to occur at the outer scope or the outer part of this particular method. And it's going to provide the overall control flow. And then internal to that, the image future and then apply async will be used in order to provide the asynchronous processing and transformations of each of those images with the transform that's being applied. So it's a little tricky, probably take a little while to get right, but it's very cool. And then the last method we have here is called transform image. Here you create and use a Java sequential stream, which itself will use a factor method to create a one-element stream containing just the transform that's passed as a parameter. You'll then use an intermediate operation to try to create a new cache item for the image, filtering out the image if it's already been cached locally. That'll give you a hint about which intermediate operation to use. You'll use another intermediate operation to apply the transform to the original image to produce a new transformed image. You'll filter out any null transformed images and return the stream of filtered images, and then you'll go ahead and use a terminal operation to count the number of non-null images that have been transformed. So in this particular case, you'll be returning a count, which in this case is an int. So those are the various methods you'll have to implement. Again, it's a little bit tricky, but very cool, and it'll give you a deep understanding of how these things work. Now that we've walked through the specification and the skeletons, let's turn our attention to the unit tests. As usual, we'll come over here and run the tests in EDU, which will start all the tests up and running. Make sure that you set the flags to just run for the graduate tests, otherwise the undergraduate test might run. We don't want to do that. What we'll be doing here, of course, is not only running the tests for the completable futures crawler that we're doing for assignment 4, but we're also running all the tests for the previous implementations as well, the ones that are the fork join pool, the one that's the parallel streams and sequential streams and the array tests and so on. As you can see, we have a lot of tests, but fortunately, all 147 of them will pass correctly if you have your code done. So make sure that you integrate all your solutions from the previous assignments as well. So the very last thing we're going to do is we're going to go ahead and run the test application. You can see over here, I come up and select the implementation for completable futures, which is here. And then I come back over and let's see, we're going to download the images or get the images locally. And then we come back over here and click download and everything starts to run. You can see that it's doing all these different processing steps asynchronously and concurrently. And you can see it's also going pretty darn fast here because completable futures are a very efficient way to do things. So it's cranking away and basically getting the images from the local device and then applying the various transforms to them once that they've been obtained, and then those get written out to disk. And you can see when we're all done, the solution is finished and everything works according to plan.